The second part of lesson 7.1 is Delta Math examples. Delta Math example 1 for dilations. The segment below is dilated by a scale of 1/4 to form segment V prime W prime. What is the measure of that segment? V prime W prime. It's scale factor of 1/4, so it's going to be a reduction. The dilation is 1/4, so we're going from larger original to smaller, so the new length is going to be 1/4 of the 44, which is 11. So V prime W prime equals 11. Now, when you're talking about a segment length, of course, you don't have the bar above it. So there you have it. Number 2, the angle below is the image formed when a figure containing angle BCD is dilated by a scale factor of 1/2. What's the measure of angle BCD? Well, all corresponding angles are going to stay congruent. So 48 degrees, you're done. Number 3, segment CD is dilated by a scale factor of 1/2 to form segment C prime D prime C prime D prime, measure 7. So that's where we end up. So the dilation's 1/2, and that is the original going to the new. You multiply by 1/2. So to go the other way around, you're going to multiply by 2. So measure of segment C prime D prime, 7 times 2, which is 14. Delta Math example 4, figure containing angle QRS is dilated by a scale factor of 2 to form a new figure which contains angle Q prime, R prime, S prime. That new angle is 44 degrees. What's the measure of the original? Well, all corresponding angles are congruent. So yes, it's still 44 degrees. Delta Math example 5. So in the figure, and this example or a problem like this in Delta Math is not going to have the setup like I do down at the lower right there. You might need to jot that down on a piece of paper because it doesn't have the coordinates there listed for you or all organized like that. The dilation's 1/3, so it should be getting smaller. Good thing we're about out of space. Reduction. Divide both the x and the y by 3 is the easier way of multiplying by 1/3. So point V is at 0, -6. Multiply by 1/3, you're at 0, -2. W's at 6, -3. Multiply by 1/3 for the x and the y, and you're at the point 2, -1. X is at 6, 3. X prime will be at 2, 1. Y is at the point 3, 6. Y prime's at the point 1, 2. And Z is at the point -9, 6. Z prime is at the point -3, 2. Connect the dots, and there is our figure. 5 sides, so that is a pentagon. Same shape, different size. Corresponding angles are congruent. Number 6, we have a triangle this time. Scale factors 3/4, centered at the origin. Of course, that's the way we're going to be doing it. So it should be getting smaller. Original point 0, or O, excuse me, is 0, -4. Multiply by 3/4. You're at -3. So 0, -3 is O prime. P is at the point 4, 0. Multiply both the x and the y, but y is 0, by 3/4. You're at positive 3. So that's the point 3, 0. And Q is at the point -8, 8. And if we multiply -8 by 3/4, we're at -6. Multiply 8 by 3/4, we're at positive 6. There we go. Connect the dots. There is our new triangle. Example 7, same kind of thing. Quadrilateral this time. Four-sided figure, scale factors 3/2. It's an enlargement. There we go. Multiply both the x and the y by 3/2. So W is at the point -4, -2. Multiply by 3/2. You get -6, -3. X is at the point 0, -6. So all we need to worry about is that -6. Multiply by 3/2, we're at -9. Y is at the point 4, 4. So multiply both the x and the y by 3/2, and we're at 6, 6. And Z is at the point -4, 6. And we've already dealt with 4s and 6s, so multiply by 3/2, we're at -6, 9. There we go. That is an enlargement with a dilation of 3/2. Number 8. Here we go again, pentagon. So dilations. 4, we're getting a lot bigger. Good thing we have some room. Enlargement. Multiply both the x and the y by 4, but let's see where they are originally. I is at the point -1, -2. Multiply them both by 4. We're at -4, -8. J is at the point 2, -2. Multiply them both by 4. We're at 8, -8. K is at the point 2, 0. Multiply both the x and the y by 4. We're at 8, 0. L is at the point 1, 1. Multiply the x and the y by 4. We're at the point 4, 4. M is at the point -2, 2. Multiply both the x and the y by 4. We're at -8, 8. And connect our dots. Should look the same, just bigger. Number 9. Determine a series of transformations that would map polygon ABCD onto polygon A prime, B prime, C prime, D prime. Select from the drop-down boxes. Delta Math example again. So there is a size change. So somewhere is going to be a dilation. Let's see here. The length of segment CD is 3. Length of segment C prime D prime is 1. So if we're going from 3 to 1, our scale factor is 1/3. It's a reduction. New to original, multiply by 3. A prime is at the point -1, 1. To get to the new, we ended up at -3, 3. Translation must have been done first because that's not where it ends up. So translation first and then a dilation. Determine a series of transformations that would map polygon A, B, C, D, E, pentagon, 5 sides, 5 vertices. Let's see, we're ending with the primes, so there is a size change. It's going to include a dilation. If we dilate based on the center of dilation at the origin, let's see, we got 3 times the length change. So dilation followed by enlargement, scale factor 3, already said that. Original to new multiplied by 3. A is going to go from 1 negative 2 to 3 negative 6. But that's not where it ended up. So we're going to have to do a translation afterwards to get to the point 6 negative 6. So translation must have happened second. Drop down box. 11. Let's see what happened here. Of course, a dilation's involved because there's a size change. It is an enlargement. First step, multiply both the x and the y by 3. A is at the point negative 1, negative 2. That's going to end up at negative 3, negative 6. The image, though, is at 6, negative 3, which must have included a rotation 90 degrees counterclockwise. So the rotation must have happened second to take the original A after a dilation onto the point A prime. This is the end of lesson 7.1. We just completed all the Delta Math examples.